The next problem, we want to verify this identity, and it says, like I've been telling you, start with the more complicated side and change everything into cosine and sine. So this cotangent is really cosine over sine. So that'd be the first step. And then, so obviously what you have here, if you follow this would be cosine. So they're looking for the first step. They ask for this part right here. And then we'd have a common, or get a common denominator. It says using a ratio, combine the terms, the common denominator. So I'll make this sine squared over sine. And we can combine these. Then we have cosine squared plus sine squared in the numerator over sine. This is just 1 in the top here, so I think that's what they're looking for. Actually, I lied, I'm sorry. Cosine squared is right here over sine, plus we're looking for sine squared. We're looking for that right there. So I went a little too far. But obviously we could simplify this even further, on our test. This would be 1, according to the Pythagorean identity, so 1 over sine is cosecant. Next problem, tangent is sine over cosine. And obviously the cosines cancel. So we just get sine. Next problem, this in the top is really just sine squared of t, because that's on our Pythagorean identities. One of these sines cancels with one of these, and we're left with just sine. Okay, next problem gives us the cosine of inverse sine of x. Now, inverse sine, anytime you see an inverse trig function, that's an angle. So I'm going to draw that angle in the first quadrant, and I'm going to say that sine of theta equals x, because that's how you write this, right? So I'm just calling this theta right here, in which case I can flip the theta. If the inverse sine of x equals theta, I can flip these two and do sine of theta equals x. So here's theta. Sine is opposite over hypotenuse, so I'm going to make that x over 1, so I get x. In which case this would be x squared minus 1. I'm sorry, it'd be square root of 1 minus x squared, according to the Pythagorean theorem. A squared plus b squared equals c squared. Now they're asking for cosine, so cosine is adjacent over hypotenuse, so it's just the square root of 1 minus x squared over 1. That's what I would enter in right there. Okay, the next problem gives us an angle between 0 and 90, so I'm going to draw an angle in the first quadrant. They tell us some things. They tell us that the sine of t is 1/4, so I'm going to draw this triangle right here. This is t. Sine is opposite over hypotenuse, which makes this the square root of 15 if you do the Pythagorean theorem. And they want then, the cosine of t plus pi, for example. Well, if I add pi, I'm looking at the same triangle, but now I have to make a straight line here and add 180. Where this would be t now, or this whole angle would be t actually. And this would still be 4, this would still be 1, this would still be the square root of 15, only now these would both be negative. And so if they ask for the cosine of this angle, it would be adjacent over hypotenuse, so it would be negative square root of 15 over 4. Okay, the next part, sine of t minus pi. Well, here's t. If you subtract pi, you're still right back to the same spot as the triangle we just drew. So this would be the same triangle, and sine of that would be opposite over hypotenuse, so it would be negative 1/4. And we're talking about the same triangle for the next one, because t plus 2 pi just goes around twice. I'm sorry, that gets back to this triangle, because here's t, and then plus 1 pi plus 2 pi takes you right back to here. So we're looking at this triangle, and the cosine of that would be adjacent over our hypotenuse, which is square root of 15 over 4. And then the tangent of t plus pi is this triangle over here, and tangent would be opposite over adjacent, so it's 1 over the square root of 15. Double negatives will cancel. Next problem is similar. They told us that t is an angle between 0 and 90. We're in the first quadrant, and then they give us this information about sine, which helps us draw a reference triangle where sine is opposite over hypotenuse, which makes this the square root of 15 again. Now we want to find the cosine of t. That's adjacent over hypotenuse, so it's square root of 15 over 4. Now negative t is just down here, so I'll draw that right here. And same thing, this is 1, this is 4, this is still square root of 15. Only this is negative now, so if they want to find the sine, that'd be negative 1/4. And cosine of that negative t would be adjacent over hypotenuse, which is still a square root of 15 over 4. And the tangent of t is opposite over adjacent, so that's negative 1 over square root of 15. Okay, the next problem, if we take a look at this, we can simplify this. If we FOIL this, we get 1 minus sine squared of x, the first two. That's just a difference of two squares, so square the first and square the last. And then we have 1 plus tangent squared. Now, before we FOIL that out again, you might notice that this is cosine squared on the formula sheet, according to our Pythagorean identities, and this is secant. That's nice because that just simplifies to 1, because secant's really 1 over cosine. So this is 1 over cosine squared, in which case we just get 1. So this whole thing just equals 1. Okay, the next one's a little trickier, but I'm going to rewrite this as sine to the 4th. Combine the terms, get the terms together. So you get this, and then I'm going to factor out a sine squared from both of the first two terms, and a cosine squared from actually a negative cosine squared from the second two. So you get this right here. Now I'm going to simplify. Sine squared of x minus 1, according to our Pythagorean identities on our formula sheet, would be negative cosine. You have to move this over and subtract 1 from both sides. So it would be negative cosine. So this is sine squared of x times negative. I'll put the negative out front. And then this right here turns into negative sine, according to our Pythagorean identities. If you subtract this over and move the 1 over, then you get negative sine. So this turns into positive cosine squared of x times sine squared of x. And these just cancel to 0. Okay, the next problem, if you just draw two angles in the first quadrant, U and V, and label them like this, and then fill out this side using cosine, or using the Pythagorean theorem. The cosine of U would be adjacent over hypotenuse, so it would be square root of 8 over 3. The cosine of V would be square root of 15 over 4. And don't worry about this, we're going to do this later. So just leave that blank for now, but we will do the sum formula later. And actually, this one as well is one that we're going to have to use the double angle identities on, which we haven't covered yet, so we're going to have to skip 17 as well. We will come back to this. The next problem then wants us to evaluate these. So once again, whenever you see inverse trig, that's an angle. So I'm going to rewrite this inverse cosine of 3/5 as theta. I'm going to call it an angle. And so I can write cosine of that angle equals 3/5. And so then I can draw a reference triangle. This is a positive angle. I'm going to draw this in the first quadrant. So I'm going to draw this here, and I'm going to say cosine of theta equals adjacent over hypotenuse, in which case this will be 4 if you do the Pythagorean theorem. And we want the sine of that. So sine would be opposite of hypotenuse. This would be 4/5. And the next one, you draw a different triangle here. Once again, do the same thing. Sine of theta equals 12 over 13. Draw a reference triangle. Sine is opposite over hypotenuse. Do the Pythagorean theorem to get 5. And then take the tangent of that same angle theta, which is opposite over adjacent, to get 12/5. The next problem wants us to simplify these again. So the first one, I'm going to pull out a negative 1, and I end up with tangent squared of x plus 1 over secant squared of x. That's pretty simple because this is on your formula sheet under your Pythagorean identities as secant squared. So these cancel and you just get negative 1. Okay, so for the next one I can factor out a sine squared of x, leaving me with sine squared of x minus 1 over secant of x. And then this on the formula sheet is actually negative cosine if you rearrange the Pythagorean identity. So I'm going to put that in right here. And secant's really 1 over cosine. So instead of dividing by a fraction, I'll multiply by a reciprocal. So I'll multiply by cosine of x, in which case I just get, I'll pull the negative up front. I mean, this is as much as I can simplify this, unfortunately. Kind of a pain to enter in, but you're going to have to enter in that using parentheses right here. And then the last one, this is an odd function. Sine's an odd function and cubed is an odd function, so basically we can pull out that negative. Kind of talked about that earlier in the year. So we get this, and then at the bottom you can factor out a sine, so you have sine squared of x minus 1. One of these sines cancels with one of these, and then you can also make the bottom negative cosine again, square root of x. So you end up with negative sine squared of x over negative cosine squared of x, which double negatives cancel, and you can write that as tangent squared of x. All right, the next one, we don't need to match these, so I'll start with the first one. Cotangent is really cosine over sine. And then secant's really 1 over cosine. And so these sines cancel and you get cosine of x minus one of these cancels. So that just turns out to be 0. So there's B. Next one might be a little tricky, but if you replace secants with x, what you'll find is you have 4x squared plus 4x plus 1. So if you recognize that pattern at all, and this is something that factors, that's a perfect square trinomial pattern, basically. So that turns into really 2x plus 1 squared over 2x plus 1. So obviously one of these cancel, and you're left with 2x plus 1, which is really just 2 times secant. We used secant for x. So 2 secant of x plus 1. Which, secant's really 1 over cosine, so I'll replace this with 1 over cosine. And what you find is it's this one, c. So there's c means this must be a. Okay, and the last one then I'm going to rewrite this. You always want to replace sine and cosine with everything. So I'll make this 1 over sine of t over cosine of t. That's what tangent is. And instead of dividing by this fraction, I'm going to put them at the top and multiply by the reciprocal. So I'm going to make it cosine of t over sine of t. So I just flipped it, put it at the top. Now I need to get a common denominator, so I'm going to multiply the top and the bottom of this by cosine of t. So I have 1 minus cosine squared t over sine of t cosine of t. And this 1 minus cosine is really just sine squared. And one of these sines cancel with one of these, so I have sine over cosine now, which is just tangent. So it turns out this whole thing just simplifies the tangent.